the sine rule. And here it is. Here is a standard wobbly triangle, because I tried to draw straight lines and my dog she was helping me. A lot of these questions are going to look very similar. So that's a good thing, because once we've done a couple of them, you'll kind of have done most of them. But there are going to be some other things later on, which we should get to today, but definitely we'll get to by tomorrow, where we start introducing some more issues that aren't always obvious, right? So that's kind of vague, but hopefully it'll make more sense later. So no particular reason, I'm going to take question 4, and they have a right angle triangle. And just to show you the way that they do the question, you'll get a picture like this. In this case, they're being really nice to you. They even go to the trouble of telling you what the sides are called. I hope by now you're all pretty comfortable that that side is A and this is B and this is C. And then up here, as part of the question, they tell you little c is 80. And that funny little symbol that looks like a thingy, that's angle A is 55 degrees. And it should be straight. It should look more like that. And angle B is 25 degrees. So these you are told. Essentially, they say solve the triangle. So what the solve the triangle is find everybody else that's missing, right? So I'm going to put in what we know. We know this guy is 80. We know this guy is 55. And we know that this guy here is 25. And there's my little degrees, right? Now, it would have been much easier if they just did this picture rather than, just calling them this and then telling you what the numbers are. But I think the reason WebAssign does that is so that they can randomize these numbers so everybody gets a different question, right? So are you okay with that? Just means this triangle, right? So who's missing? Well, if you remember what we did yesterday, we got a kind of list of things to do. Haven't already done the name the sides thing. Is there any angle that we can find right now without doing anything too clever?
We can find C.
Yeah, we can find.
Agreed. So if you add the two guys, and thankfully they're nice numbers, I believe you get 80. And so are we comfortable that that angle there is 100 degrees? And when you go and you do your answer in WebAssign, there'll be a guy like that and equals a box, and they put the little degree symbol, which means you don't need to worry about it. And you would just type in 100. So that's what it would look like in WebAssign, right? You just put in 100. Because the little degree is there, you don't need to put it here. If they're really annoying, won't they sometimes, like yesterday, forget to put the degree in there, in which case you have. Has anybody tried to put a degree in the box when you didn't need to? And did it say you're wrong? I'm just curious. Well, no one's done it, or it didn't say you were wrong?
I just haven't done it.
Right. When you've got time, because you got 5 guesses, will one of you do it and then tomorrow say, yeah, I did it and it was okay? Or, yep, I did it and I had to undo it because it didn't like a degree inside a degree, right? And that way everybody will know. Because I can imagine you do everything right and then you just don't notice, why am I not getting the right answer, right? Why is it saying it's wrong? Okay, we got this guy. Then we go hunting for either B or A. Now, in the way this triangle is set up, once you know all 3 angles, it doesn't matter which one you go for first and which side you go for second, right? They both work. So I'm just going to randomly pick A. So I'm going to go hunting for A. So you write down the sine rule. And then according to kind of the process, the steps of yesterday, you tick off all the things that you know. And since I said we're going to find A, you also tick off things that you want to find. So in this particular combination, Do you see almost everything has got a check mark on it, right? And only 2 out of the 3, right? Only A, B, C, only 2 out of those 3 get used at any given time. I think it's pretty clear here. Isn't it going to be the outside 2? So I'm going to do it kind of a little bit more than you need to. But there's the 2 I'm going to use. And now I fill in all the things I know, and then we'll see what's missing. Well, I know angle A is 55, so that's going to be the sine of 55 degrees. And I don't know little a. I know C is 100, so that's going to be the sine of 100 degrees. And I know little c is 80. In the few questions that we've done, have you noticed that you always end up with a fraction and you always do cross multiply, right? So the calculations are going to look very similar. So cross multiply. A times the sine of a 100 degrees, that's going that way, is equal to 80 times the sine of 55 degrees. And that's pretty much guaranteed. So what do I do to both sides to find A?
By both sides by sine of 100 degrees.
I agree. And so off we go. And do it. It's going to be 80 times the sine of 55 divided by the sine of 100. And I get 157.9. What do they want? 2 decimal places. So 0.95. And I put it in. And WebAssign says I'm wrong.
Yeah, I got like 55 something, so I believe you're in ratings, right?
I am. I deliberately did it. You see how easy it is to forget which one you're in? So it's one of those little mistakes, but you know, it kind of has to be fixed. So since you've already done it for me, if you do it again, did you say 55 point something?
I think it's 55 right now.
Okay. I could double check it. 80 times the sine of 55 divided by the sine of 100. Sine of 100. I get 66. You check that?
Yeah, we scratched that.
Okay, that's fine. So 66.54 degrees. So I'll go up here and I'll do 66.54. No, it's not degrees, it's the side. So it's that one. So there'll be a little A equals, and this is much easier, 66.54. And then I can do B. I'm not going to do B. Would you agree it would just be virtually the same kind of question again, right? And cross multiply and do your thing. So I have, well, actually, I do know what the answer is. It's 34.33 if you were doing it. How comfortable do you feel about using the sine rule to find the rest of a triangle that's missing, right? The bits, the angles and the sides that are missing. Feel good? Right. So that's what I want to hear. We feel good. So let's pick anything interesting here. No, I done that one. Okay, There's a weird question. That's why I'm pausing, because I'm wondering what the heck they're talking about. But question 7 has a weird thing going on here. They tell you angle A is 55 degrees. They tell you that angle B is 78 degrees. And they tell you little c is 270 units long. And I've got a triangle that looks something like this. And this is A, this is B, and this is C. And little c is 270. Angle A is 55 degrees, and angle B, which is over here, is 78 degrees. So far, so good. Now, part of this question is pretty straightforward. It's the bit at the end that I'm not talking about yet, but I'll get to it. That's the weird part. So, very like question 4. Would you agree that the first thing you're going to figure out is angle C? Right? Always look for an angle you can get. Not doing this in my head because I know how careless I can be. So I'm adding these guys up. And I get, what, 133 degrees. So that leaves me with 47 degrees. You comfortable about that? 47. You could probably do it in your head, but I didn't want to. Okay. Sine A over A, sine B over B, sine C over C. Okay. Check off everything that you know. And what you want to get. Isn't this one of these situations where either side is okay? So if you know 3 angles, it doesn't matter. Do you want me to go for B first, just because I went for A the last time? Yeah, okay. So that's the one I'm checking. So this time, it's B and C that we're going to use. And I'll save a line of working, because I'm just going to use that straight from it. So it's going to be the sine is 78 degrees over little b is the sine of 47 degrees over 270. Cross multiply. B times the sine of 47 degrees is 270 times the sine of 78 degrees. And if you divide both sides by the sine of 47 degrees, you get your answer. And I am in degrees. So I have a 270 times the sine of 78 divided by the sine of 47. And the answer I come up with is 361 point, to the nearest whole number. Okay, I'm happy with nice whole numbers. 361 is the answer. So this guy here, right, is 361. And I'm just going to tell you A is 302. Now the weird question. They give you 4 pictures. And we have to choose which one of them actually is the right one. And that looked weird to me until I figured out what they were getting at. So let me show you that question. And maybe someone can tell me. Oops, get somebody in the chat. Okay, I think I could shrink this a little bit. There we go. Right. One of those triangles, and only one of those triangles, is in fact the right shape.
Is it the
And you
bottom
might-
left?
Oh, so you're going for that one. Is that correct?
Yes. Because
Okay.
this C is across from each other.
What do you mean by the C is across from each
Oh,
other?
sorry. Like this, like the angle C, like 270 has to be like on the other side of C. And that's the only one that it happens.
Ah, right. So let's show you what you've got there. Do you see 270? Now, what was the angle that we had for C? The angle we had for C was 47. Wouldn't that be there? You see that angle is opposite it? Well caught. And that was not how I was going to answer that, but it is correct. Your logic is perfect. So now I'm going to show you a truism about triangles. So this is true about every triangle in the world. I'll try and make it not right angled looking. This is the biggest, right? This is the longest side. This is the smallest side. And this is the middle side. So can you imagine that for most triangles, except for isosceles, I guess, isn't there going to be one side bigger, one side the smallest, and one is in between the two, right? Now, the biggest angle is always opposite the biggest side. The smallest angle is always opposite the smallest side. And the middle angle is always opposite the middle side. So you could have answered that question that they gave by using that property. So let me show you how it would work. I have to make one of these. Sorry about the bend. Right, here's a very badly drawn triangle. And I'm going to tell you that one of them is 14, one of them is 27, and one of the sides is 9. Okay. Which one of these three sides is going to be the one that's 27? And I don't want to put A, B's, and C's in it, so I'm just going to randomly call them side 1, side 2, and side 3. Which one of them is going to be, like I said, 27? So which one of them is going to be 27 units long?
3. I'm sorry, 3.
Great. Isn't that the biggest angle? So that's the biggest side. Which one of these then is going to be 14?
1.
Right? Isn't that the middles? And so wouldn't the other one be 9? Did anybody know that property before about triangles? That the biggest side is always opposite the biggest angle and so on? Yeah, you may have heard it and forgot about it and it's came back. Okay. You know it's not a property that's going to be used tons and tons of times. It's had its day and that's it. There might be one other question where they show you a triangle and say, which one of these four is it, right?
I have a question really quick.
Yes.
Sorry, it's kind of loud. So is the only exception, like 'cause you said almost all triangles, so is the only exception the 45, 45, 90 triangle when the two sides are the same?
Well,
Is it, like, the only time it doesn't work?
Any isosceles, it would work. So if you had an isosceles triangle, right? And this was 100, obviously these two would be what, 35 each.
Oh,
Then
true.
this one is the biggest. And won't these
Gotcha.
two be the same size? So it really don't matter.
Never mind. Yeah, okay, I got that.
And right angle triangles are normal because even for a right angle triangle, what I just said would also work. Right? If you drew a right angle, the hypotenuse is the biggest, it's opposite the 90. The other two are smaller, right? And they're going to be the other two sides. So just a little idiosyncrasy, but I did like the way that you figured that one out, which was totally different from the way my brain was working. But I like things like that. It just is cool. I'm just zooming through some questions here. 8 and 9 are pretty much the same, guys. So I'm going to do another question, only this time the information is going to just be a little bit different, but it's still going to be the sine rule. And once I've done that, we're then going to move on to a slight awkwardness in the answer. I don't know how else to describe it. You would expect that a triangle with given information was unique. In other words, there's only one answer to the puzzle. And 90% of the time, there is only one answer to the puzzle. And the one I'm about to do, there's only going to be one answer to the puzzle. But there can be questions, as you'll find out after this one, where there is going to be a possibility of two answers. Or no answer at all. In other words, the numbers that you gave me couldn't make a triangle, right? The triangle doesn't exist. So, but they're the special cases. So I'm kind of jumping ahead here. So here is my triangle. You know, no matter what I do, it doesn't always end up looking like right angled. I can't help it. I guess my brain just wants, that looks like a corner to me, but it isn't, right? In fact, there's no reason for anything. So there's my generic triangle, and I need to put in some numbers here. So I'm going to put in 100 degrees, and I'm going to make this 25. And I'm going to make this 10. So in this question, it's, solve the triangle, right? Find everybody that's missing. So I'm going to name some sides. So this is little a, right? This is little c, this is little b. Is there any angles that we can get? Not this time. So what do I know? I know C. I know little c. I know little b. Which angle do you think I should go hunting for based on the 3 check marks?
B. Wouldn't this be the case where there is more than one answer though?
I hope not. I tried to design it not to be.
I thought it's for all, like if you only have one angle, then the other two could have like more.
Some can and some can't. You're
Okay.
right. I think I've designed this one to only have one answer. And my fingers are going to be crossed that that's the case. The one after this is going to definitely have 2 answers in it. And it'll look very similar. Right. And then the one after that's going to have no answers. And it's also going to look very similar. So the questions will look as superficially like it's the same question. And there's no reason why that dotted thing is, just emphasized. So the sine of b over 10 is going to be the sine of 100 degrees over 25. We all comfortable with where the numbers are coming from? Yeah. Cross multiply. 25 times the sine of b is going to be 10 times the sine of 100 degrees. So the sine of b is 10 times sine of 100, and you divide everybody by 25. So here goes. Oh, no, I did this last time. Can I actually do it in one go? What would I need to do to both sides to find angle B?
Take the inverse line.
I think it's easier if you just do one big horrible calculation than to do it twice. That's the only reason I'm doing this. So switch it on, clear out the old stuff. It's going to be the inverse sine of 10 times the sine of 100 divided by 25. And the answer I get is 23.1. Good. This one only has one answer. Right. So I now know it's
Why would
green
it-
loading. Oh,
Sorry.
how do I know there's only one answer?
Why would it not also be like 100 and
Great question. The other possible answer, and I'm doing my little faint dotty thing here, would be, you know, if you do a sine, you've got an angle over here, but there's a possibility of another one over there. And so the other one would be 100, if it was possible, would be 156.9 degrees, right?
But don't signs have to be in the first and fourth quadrant?
Well, for sines, as far as the angle goes, it's first and second quadrant when we deal with triangles. As far as the inverse sine function goes, what you said is correct. I know it's a contradiction, but it is what it is.
Okay.
When you're dealing with physical triangles, you can't really get negative 10 degrees, right? Because that isn't physical. But you could get angles in the second quadrant. Couldn't you get angles of 100 degrees? So this could be the second answer. And the reason why it doesn't work, which brings me to your question that you were asking, Cassandra, is that guy's already 100. I don't have enough room for 156.
I see, that makes sense.
So
Yeah.
the
Also,
next question, the
the,
next question,
answer-
say again?
The answer is slightly wrong. It's actually 23.2.
Oh, it rounds up.
In exact terms, it's 23.1988. So it would round
Okay.
up.
There we go. Rounding up it is. So 23.2 goes in here. And that's B, so it goes down here. Now I know angle B. What would be the quickest way to get angle A without having to do all this again?
Just subtract 123.2 from 180.
You're comfortable, the two that you know, what's left? That ends up being 56.8 degrees. And I'm not going to finish this off, but couldn't we get the side A by just doing another one of these? And I could, because of knowing so much now, I could do an A and a B, or I could do an A and a C. It wouldn't matter, you get the same answer. So this question was really how do you find a missing angle? And in this particular case, there's only one correct answer. Now, when you are dealing with triangles, physical two-dimensional objects, two properties have to be true, right? Isn't the first one, all three must add up to 180? Right? Every triangle, all three must add up to 180. So if I have some angles in here and I add them up and it's 210 or 170, I'm wrong, aren't I? I've screwed up somewhere. Something's not right. That's the first answer, right? The second thing is that negative angles don't exist. Right? In a right angle triangle, you can't say that's minus 40. Right? Now, the inverse sine function has its own little peculiarities, but as far as we're concerned, in the way that we're using it right now, the answer you get is the right answer. Right? And there might be two. So here is how you can end up with two different solutions. So these are questions with two solutions. What we mean by that is that there can actually be two different triangles that have all the information that you've got. So here is my standard triangle, my ABC guy. And the question that we're going to deal with is going to be question 10. But if you want to see others that do the same thing, question 11 is also going to be an example where there are two solutions. And I'm doing a quick scan through. 13 has two solutions. And that's it, right? So it's going to happen about 3 times. Now, in this particular question 10, which is one I'm doing, you're told that little a is 36. So let's put in little a, little b, and little c. And you're told that little a is 36. And you're told that little c is 46. And you're told angle A is 39 degrees. So remember this one Cassandra was talking about, what about the other possibility, right? You should always be aware that there may be a second possibility. And we'll talk about it here because it works. But if you want to know when I should even bother to look, if the angle that you know is bigger than 100, the first answer you get is the only answer that's right? Don't look for a second one, it ain't going to happen. But if the angle they give you is less than 90, right? If it's less than 90, you should at least try out for the second angle because there's probably going to be one, right? Now, if that second angle, let's just pretend for a minute that I go looking for angle C. And one of the angles I get is 80 degrees. The other possibility is going to be 100. 100 can fit here, right? There's enough room. Let's suppose that angle C was 110 degrees or something. No, that's a bad choice. Try to think of one where the answer would be too big. Yeah, can you imagine that we got the answer that C was 3 degrees? Then the other possibility would be 177. Do you see there's not enough room for 177? So you're going to find two answers, right? So whenever you only know one angle and it's less than 90, you're going to find two possible answers. And sometimes both will work, and that means two triangles. And sometimes only the first one will work, and we'll discover it as we do it. So, ready to get started. I have sine A over little a. I have sine B over little b. And I have sine of angle C over little c. And I will check off, oh, that one, and that one, and that one. Would you agree that we have to use A and C? So that means I'm going to go hunting for angle C. Are you comfortable with that? Right. So, oops, it's different colors. Sine A over A is equal to sine C over C. The sine of 39 degrees over 36 is the sine of C over 46. You do the cross multiply. If you divide both sides by 36, and then you get C, and that is going to be the inverse sine of all of this. Nothing that I've done is really any different from the other questions, which is good. And this answer is going to be fine. So it's going to be the inverse sine of 46 times the sine of 39 divided by 36. And I'll try to be more careful. to, I would do 1 decimal place, 53.5. And I'm going to call that guy C1 for what angle C could be, right? The first answer. That one's always going to be fine, right? And if you get an answer, it's good. Now, I said there could be a second one. If you remember all sine, tan, cosine, remember that, guys? Aren't sines positive in the first and the second quadrant? And we are looking for a sine that's, well, we know that one, right? He is 53.5 degrees. Isn't there another guy over here who's also going to have the same answer as the sine of that guy? And he has the property that this angle that it makes with the x-axis is also 55.3. So my second possible answer is going to be 100, take away that. 180, I should say, take away that. So whatever this answer is, the other answer is always going to be 180, take away 53.5 degrees. So if you're doing the sine rule, the answer you get is the first one, and 180 take it away is your second one. Now let's see what that looks like. That's 126.5 degrees. Now you go to the question. That answer is 39. Do you have enough room for 126.5? Will that fit? Right, 39. Is there enough room for another 126.5? Yeah.
Yes.
So do you see that is a second answer? So what I'm going to do now is pause for a minute and try and keep that together as long as I can. And now show you the two triangles. And I'm not going to try and draw them to scale, because to me, that's not that important. Just a generic triangle in both cases. A, B, C, A, B, C. This angle is 39 degrees. This angle C, the first one we got, is 53.5 degrees. In the second situation, this one is 39 still, and this one is 126.5 degrees. And if you're wondering when I say, is there enough room? If you add these two up, as long as it's less than 180, there's enough room. That's what I mean. That makes sense? You've got enough room. Now, if I put in all the other details, it's going to take me a while, but here it goes. A, B, C, A, B, C. This is still 36. This is still 56. This is still 36. And this is still 46. Do you see that we now have slightly different information on each triangle? What is still to be found? Well, don't I now need to find angle B? Now, in this question, to get angle B, don't we add up these two guys and take it away from 180? And I'm doing it the slow way because I don't want to risk screwing it up. So that's 92.5. So 180 take away 92.5 degrees gives me 87.5 degrees. In this one, the two guys that we have are 39 degrees and 126.5 degrees. And we add these two guys up, we get that. And so the angle that's left is 14.5 degrees. Are you comfortable about the two triangles now are generating different sizes for angles as well? Now, if I went to this triangle, couldn't I then do the sine rule and find out the length of B and then do, well, that's it finished, right? And for this triangle, couldn't I also use these numbers and find out the size of B? And I have this answer in front of me, thank goodness. No, I don't, but I will in a second. I forgot what question this was. What question was this?
10, I think.
I think it was 10. Good. We are good. So in this one here, the B ends up being 57.1. And in this one here, B ends up being 14.3.
So
Yeah.
in the homework, do you have to solve for both, or do you
Yes.
choose?
You
Okay.
solve for both. So the way it looks like in the homework is that this will be called angle B1,
Okay.
angle C1, and little b1. And this will be called angle B2, angle C2,
Okay.
and little b2. And did they tell you? Yeah, they tell you B1 has to be the larger. So the guys that go here, you put the biggest B. And for the ones that go here, you put the smaller B. I could try and draw what these true triangles might look like, because right now they look identical. So if I try to draw this angle, the angle at the center would be quite big. It would be about 126.5. This angle would be 39, and this one here would be 14.5. If I try to draw the second one, but keep everything else pretty much the same, this angle would be 53.5, 87.5, and 39. Physically, don't they look different as well? Are we good? Right, I was going to, but I'm not going to have enough time, so I'll make sure I do it tomorrow to show you a triangle that has no solutions. In other words, the triangle doesn't exist. But for the last few moments, why don't you lot, while I'm doing this, say your last name for attendance. And while you're doing that, we'll just have another look and show you what's in Canvas. What do you mean service is currently unavailable? Don't you even think about doing that. Okay, I will tell you very quickly what I was going to show you. And I hope I've mentioned it before, but I'll mention it 3 or 4 times, because somebody on Monday is going to say, what midterm? I'm meant to be here at 9 or whatever. And when that person says that, Lena, won't I be allowed to swear at them?
Definitely. Yeah.
Right. And
Okay.
so you will all put on mute so I don't offend you, right? And if we were in a class, wouldn't I also be allowed to throw things at them? You are very generous. No, my boss has told me, stop throwing things at students. Evidently, there's a rule in America where if you throw things at students, you can be sued, you know, because they lost an eye or something like that. But anyway, what I was about to tell you is, you know the midterm is on Monday. You know that it's going to be, in our case, from 9 till 11. Also, in case I haven't mentioned it, and I'm sure I'll do it again, midnight on Sunday is a drop dead date for all assignments. There will be no extensions. So normally you get an extension, but week 5 is a cut-off date. So I'm forcing you to get ready for the midterm Because how can you do a midterm if you haven't done half the homework, right? You got to force yourself. So week 5, midnight, don't ask me because you ain't getting one.